Hello and welcome to Unify access to siloed data with AWS AppSync GraphQL resolvers. My name is Nader David. I'm a senior developer advocate on the AWS web and mobile team. Today we're going to be talking about AWS AppSync, and we're really going to be focusing on the different types of resolvers that you can use with AppSync. The two that we're going to be really spending a lot of time on are Lambda resolvers and direct resolvers. But first, we'll do an overview of what GraphQL is and what AppSync is. And then to end off this presentation, we'll be doing a live coding demo where we're going to be building an AppSync API using AWS CDK. So AWS AppSync is a managed GraphQL API service that allows you to build real-time and offline apps using a single API endpoint provided as a GraphQL endpoint. Using AppSync, you can have access to all of the different data sources within your account, databases or otherwise, but you can also have access to data sources outside of your AWS account. So a lot of companies and customers are using AWS AppSync as an API gateway layer into all of the different microservice architecture within their app. Built into AppSync are offline and real-time functionality. The real-time functionality is built in using a implementation of GraphQL subscriptions. The offline functionality is built in using a combination of the service layer along with SDKs and libraries that are supported by the AWS mobile team. With AppSync, you can use either the libraries and SDKs provided to you by the AWS mobile team, or you can use third-party libraries like Apollo or Urkel. And then using those libraries, you would interact with the endpoint that's given to you by the AppSync endpoint or the AppSync service. Within AppSync, you'll define your GraphQL schema. Within your schema, you define the data as well as the operations that you would like to have to interact against the data defined in your schema. You define your resolvers that map the operations from your schema into the various data sources. And then within the AppSync service, you can use either direct data sources like we're going to be going over in just a moment, or you can use a Lambda function as a gateway into any data source that you would like within or outside of AWS. So to talk about AppSync, let's first kind of go over what a GraphQL API consists of. A GraphQL API consists of three main parts. You have your schema, you have your resolvers, and you have your data sources. The GraphQL schema is essentially a combination of the data as well as the operations that you would like to have that operate against that data. So in this example, we have a really basic to-do app where we have a to-do type with a few different fields. And then we have a query and a mutation that allow you to interact with that data type of to-do. So the query would be for fetching data, the mutation would be for creating or updating data. When you think of a GraphQL API, it's really easy to map the different operations against the traditional REST API using the traditional HTTP verbs. So when you think of a GraphQL query, you could easily map that to a GET request. And when you think of a GraphQL mutation, you could really think of in a HTTP verb, something like put, post, delete, or patch. So in this example, we have a get to do, which would be our query, and then create to do, which would be something like a put or post request. Using the different types and the different operations, you would then define your data source, and the data source would be where the data is going to be placed or retrieved from using the different GraphQL operations. Finally, you have your resolvers. The resolvers are going to be essentially functions that allow you to define the business logic that happen between the GraphQL schema and the data sources. So this brings us to the AppSync resolvers, and this is really what this presentation is about. With AppSync, we enable three main types of resolvers. The first are direct resolvers. Direct resolvers allow you to have a direct mapping between the GraphQL operations and data sources within your AWS account. The second are Lambda resolvers. Lambda resolvers allow a little bit more of an escape hatch, so you can map your GraphQL operations directly into the AWS Lambda function via an event, and then within the function, you can interact with either data sources within your account or outside of your account. And then finally, we have HTTP resolvers. HTTP resolvers allow you to map your GraphQL operation into a microservice architecture by allowing you to bring in any HTTP endpoint. So if you have an existing HTTP API, you can map your mutations and queries directly into these HTTP endpoints. So let's walk over the first two that we just went over there, direct resolvers and lambda resolvers. And the first one we're going to take a look at is direct resolvers. Direct resolvers allow you to, again, map your GraphQL operations directly into AppSync service into a data source that is supported by AppSync. And right now, AppSync supports three main direct resolver data sources. The first is Amazon DynamoDB. The second is Amazon Elasticsearch. And the third is Amazon Aurora Serverless. So let's take a look at a basic type and kind of see how this works. So in this example, we have a product type and we have a warehouse type. And then we have a query that kind of combines the product and the warehouse type to retrieve the ID, the name, and the price from the product, and then the warehouse ID, the name, and the location from the warehouse together in a single query called getProduct. This query takes in an argument of product ID and returns the product, which combines the product and the warehouse. And then the data that we want to get back is going to look something like this. We want to get the ID, the name, the price, and the warehouse information from the product type. So we could use the AppSync service to actually map this single request into multiple data sources. So let's say that we have the ID and the name stored in DynamoDB. This operation can map that data from DynamoDB. It can then fetch the price. Let's say this price might need to be dynamically calculated for some reason. This can be retrieved via a Lambda function because maybe we need to have some additional business logic going on there. And then the warehouse data might come from something like Aurora. Maybe we need SQL for this type of data. So using a single GraphQL operation, we can map this single request into all these different data sources. And this is done using the request and response mapping templates from AppSync. The request mapping template is what sends the data request to the data source. So this could be something like a put item or a get item request to DynamoDB, and the response is going to be whatever is returned from that data source. So, for example, let's say we want to do a put item operation. This is what it would look like when we're working with DynamoDB. We're setting the primary key, we're defining the operation, and then we're defining the values that we want to pass in. In this example, we're passing in context.arguments.input. And the context is something we're going to be deep diving on in just a moment. The context is essentially going to be giving you a lot of different values about the execution environment, as well as functions that allow you to do things within the Lambda resolver execution environment. The response mapping template is going to be the response that comes back from the data source. So if you're creating an item, you might just be returning the data that you passed in. If you're fetching data, this is going to be the result of the query or whatever operation that you're operating against your data source. Now, we see this context object, and this is really kind of the meat and potatoes, or the bread and butter of what is going on in these requests. So let's take a deeper look at what's going on in this context. Because in this example, we had that context.args.input. Let's take a look at what that actually means. In the context, we have four different properties. We have the arguments, we have the source, we have the result, the identity, the request, and the info object. The arguments are going to be a map that contains all of the GraphQL arguments for this field. So for a create operation, this might have the ID as well as additional metadata. So for a product, this might have the product price, the product inventory, things like that. We then have the source, and this is a resolution of the parent field. So let's say we have that example that we looked at just a moment ago, where we have a product, and then the product has a warehouse. Let's say we needed some metadata off of that product to actually get the proper warehouse. We could use the context.source within the context.source, which would be the resolution of that product, to fetch that information if we needed to do that. The result is going to be only available in the response mapping template, because this is going to be the actual result of the operation. So when we're passing in the request, we're only going to have the first two and the last three. The result is only going to be available in the actual response. If we're making an authenticated request, we'll also have the identity populated. If we're making an unauthenticated request, this will be null. But if there is a signed-in user, this will have the ID token of the signed-in user. So here we could get things like the user's email address, or maybe some type of other metadata associated with their signed-in user attributes. The request is going to have information about the request. So typically, this is going to be used for getting information out of the headers. And then finally, we have the info object. And this is GraphQL specific. This is the actual GraphQL info object. And this is actually pretty helpful and pretty useful. So let's take a deeper look at that. The info object, again, takes or contains information about the GraphQL request. So if, for instance, it has the field name, the parent type name, variables, and other things. The field name is going to be the actual GraphQL operation itself. So again, if we go back and look at the example that we looked at just a moment ago, where we have a type of query, and we have that get product, the field name would be get product, and the query would be the parent type name. So any operation that happens, the info object is going to contain both of these pieces of information, and it's kind of useful, and we're going to be looking at this in our example in just a moment. We also have the variables, so if there are any variables passed in, that will be available here. And then we then have the selection set list and the selection set list, or the selection set GraphQL. The selection set list is going to contain any of the values that you would like to be returned from this operation. So if we did a get product and we wanted to return the ID, the name, and the price, all of these things would be available in this array of selection set lists. And the selection set GraphQL is essentially just the selection set list, but formed in the GraphQL schema definition language. So that's the direct resolvers. Now let's look at Lambda resolvers. Lambda resolvers are extremely powerful because they allow you to just map your GraphQL operation into a Lambda function where you have complete control over the business logic or whatever you would like to do here. So let's take another example and take another look at this get product query. So let's say we wanted to map this get product query into a Lambda function. How would this look? First of all, we would have our handler function like you typically would in any Lambda function, right? The interesting thing, though, is where we were having this context object in the direct resolver, in the Lambda function, you just have the event. The event contains all that information that we just looked at that was part of that context object, with the exception of the response. So you have everything except for the response, because in Lambda, you're going to be returning something, and that is going to be the response. So you don't really need that response. So in the function, we might do something like, we might check out what is the field name, right? So what is the actual operation that's happening here? And in the example that we're looking at, the field name is going to be get product. The parent type name is going to be query, but we want that field name because therefore we can tell like what operation is happening here. So we might do something like a switch statement where we can then determine which operation needs to happen. In this case, we're going to be calling the get product function because the query field name is get product. So we can then determine which operation we want to happen here. And then we can additionally take the event arguments to determine whatever metadata we need to operate against our database. So in this example, we're going to be passing in the product ID that is coming off the event arguments. So in the get product function, we might have some operation that's operating against either DynamoDB or maybe some other type of database where we need that product ID. And this is going to be available in the event arguments. So again, just like in the context object where we have all of that different metadata, the event has all of that similar metadata with the exception of the result. So we have the arguments, we have the source, we have the identity, the request, and the info. So all that stuff is going to be there. So if there is a signed-in user, the identity will automatically be passed as part of the event in the event.identity. What's really interesting with AppSync is that you can implement a lot of the best practices that you typically see across all of these different data sources or databases. So a lot of people ask about single table design with DynamoDB and AppSync. And this is actually really easy to do, and it's actually entirely possible, and a lot of people are doing it. So if you think about the different data access patterns that you need with DynamoDB, you typically are thinking of operating against the primary index as well as different global secondary indexes, working with sort keys and partitions and things like that. With AppSync, you have complete control of that context object. You also have complete control of the event in a Lambda. So therefore, you can pretty much do any of these different data access patterns that you would expect using DynamoDB single table design. So what are the different deployment options? They're actually completely wide open deployment options because AppSync is supported by CloudFormation. So you can use AWS CloudFormation, you can use the serverless framework. The two that I'm going to go over today, though, are going to be AWS Amplify and AWS CDK. So some of the advantages of using of Amplify is that Amplify kind of supports not only GraphQL and AppSync, but it enhances the the API layer with a few different pieces of functionality that are not available elsewhere. So for instance, we have GraphQL code generation as part of the Amplify library, meaning when you create a GraphQL schema, the Amplify CLI will introspect your GraphQL schema and create all of the different GraphQL operation definitions locally for operating against its API. So if you're working on a web project or an iOS or an Android project, it doesn't really matter. It will determine based on the platform you're on, and it will create the GraphQL operations locally, so you don't have to write those yourself from scratch. There's also the GraphQL transform library, which will basically take your GraphQL schema, allow you to decorate it with different directives, and then add additional resolver functionality for you. So it will be basically writing your resolvers, adding things like different relationships using the @connection for one-to-many, many-to-one, or many-to-many relationships. You can define authorization rules using the @auth directive. So the GraphQL transform library has, I think, 6 or 7 different directives that allow you to do that. It also allows you to automatically generate boilerplate. So if you're kind of creating a new API, you can choose from a few different boilerplates to get started for different types of APIs. And then finally, and most really, the biggest differentiator, I think, is Amplify Data Store. So Amplify Data Store is a combination of service layer as well as client layer offline functionality. So using Data Store, you have kind of a new programming model where you're not even using GraphQL locally. You're able to use the Data Store API and work with local data, and then the Data Store API and the Data Store service will sync all of your data locally. So you're working with a local programming model, and the data just syncs to your API automatically. And for Data Store to work, you need GraphQL Data Store enhanced resolvers. So therefore, the CLI is kind of the only way to make that happen right now. So to add a GraphQL API with AppSync using Amplify, you just run Amplify add API. From here, the CLI will walk you through a bunch of different questions and allow you to kind of stand up your API. The next way that we're going to look at is using AWS CDK. Using CDK, you're going to use the AWS AppSync constructs and classes. So you would install that using npm, and then you would be able to then create APIs using the AppSync construct and classes. So in this example, we're creating a new API. We're giving the API a name. We're defining the location for our GraphQL schema. It's going to be in GraphQL/schema.graphql. And then we're defining a Bates authorization type. And in this example, the authorization type is API key. You can then define additional authorization types. So if you want a mixed authorization scenario, we have both public and private access. You can define that here as well. After you create the location for your schema, you would then define the actual schema. So for this example, we have something pretty basic where we have a note type, we have a mutation for creating a note, and a couple of queries for listing and getting a note by ID. Once we've done that, we then can either map the data source that we just created now, or the API that we just created there, into direct resolvers or Lambda resolvers. In this example, we're going to say we want to map our operations into a Lambda resolver. Therefore, we need a Lambda function. So we create a function, and then we can use the API we just created to add the Lambda function as a data source. To do that, we just call api.addLambda data source, pass in an ID as the first argument, and the Lambda function as the second argument. And then from here, we can just start mapping our GraphQL operations directly into our Lambda function. So we can say we want to create a resolver for getNote by ID. We want to create a resolver for list notes. We might want to create a resolver for createNote. And that's it. It's pretty simple to use CDK to create APIs. It's actually a really fun way to do it as well. And that's what we're going to use in this demo. So let's go ahead and jump to the demo. And what we're going to do here is create a new API from scratch using CDK and test it out. So to get started, we're going to create a new CDK project. And to do that, we're going to create a new directory and then initialize a CDK project using the CDK CLI. And we're going to say CDK init, and we're going to set the language as TypeScript. After we've created the CDK project, we'll go ahead and install a couple of dependencies. So what we basically need to do is install the dependencies that we're going to need for this API. So since we're going to be using Lambda resolvers, we're going to be installing AppSync, but also AWS Lambda. And then we're going to be using DynamoDB as the database within Lambda. So we'll also install the DynamoDB constructs and classes. Next, we'll go ahead and open the project in our text editor. So to get started, at the top of our file, this is where our stack lives. We'll go ahead and import all of the different constructs and classes that we just installed a moment ago. So we'll need to import CDK core, but also AppSync, DynamoDB, and Lambda. After we've imported all of the different constructs and classes, we can start writing some code. So we'll go ahead and create the API here. Here we're giving the API a name, we're defining the location of the GraphQL schema, and we're setting the authorization type as public by setting an API key, or authorization type as API key. After we've created the API, we'll go ahead and now create our Lambda function. Using the Lambda import that we just imported at the very top of the file, we can basically say new lambda.function, pass in the scope, which is this, the ID, and then we can set a different additional metadata about the Lambda function. So here we're basically setting the location for the handler, where our code is going to live, and setting a memory size. And then finally, we go ahead and attach that Lambda function to our API as a data source. And now we can start creating resolvers onto that data source. So here we're creating a query, and we're creating a mutation, and now we're ready to start writing some Lambda code if we wanted to. The last thing we want to do, though, is define the database where we're going to be interacting from the Lambda function. Because not only do we need to create the database itself, we need to allow IAM access from the function to the, from the function to the database. So to do that, we create the table. We then call posttable.grantFullAccess, which allows IAM access. And we set an environment variable called posttable. Now we'll go ahead and create our Lambda function code and our GraphQL schema. So to do that, we'll go ahead and create a folder called GraphQL and a file called schema.graphql. Here we'll have our base type for post, we'll have our input type for post input, and then we'll create a mutation for creating a post that takes in a post as an argument, and a query for listing posts, which returns an array of posts. And to add real-time functionality, all we now need to do is define a subscription. And here we're saying we want to subscribe to on create posts. When a new post is created, we want to be able to kind of listen to that in real time. So all we need to do is pass the @AWS_subscribe, passing in a single operation into the array there. And after we've defined our schema, we can now write the code for our Lambda functions. So we'll create a folder called lambda-fns. And within this folder, we'll create a few different files. First of all, we need a post type. And this post type is what we're going to basically be using to map our, it's going to actually very closely resemble the post type in our GraphQL schema. Main is going to be our entry point. And then we're going to create a function for create posts and list posts. For the post type, we have an ID. We have a name and a content field, very similar to our GraphQL type that we created just a moment ago. List post is going to be using the AWS DynamoDB document client to call a scan against our DynamoDB table. And from there, we're just going to return whatever data is returned from that operation against DynamoDB. Create post is a little different. Create post is actually going to be taking in an argument, whereas the scan operation didn't really need anything, but here we're taking in the posts. Therefore, we're using that post type. We're using the table name coming off of the process.env environment variable. Here we pass in the params, and then whatever data is returned, we just return that in the response. And then finally, for our main function, this is going to be our entry point. This is our handler. We go ahead and import create posts. We import list posts. We import the post type. We then define a TypeScript type for the AppSync event. And this is basically going to have the GraphQL info object with the field name, as well as the post as the arguments. And then here in the handler, we have that event. We'll go ahead and log that out, and we're going to be looking at that in just a moment. And then we can call switch on the info.fieldName. If it's create post, we call the create post function, passing in the post. And this is coming off of the event.arguments. And if it's list post, we just call list post. We don't need any information off of the event past that for the list post operation. So we're pretty much done here. So we can go ahead and close everything and make sure we save our files. We'll go back to our CLI and we'll run a build. Since we're writing TypeScript, we need to go ahead and run a build to turn this into JavaScript, and then we can run CDK diff to kind of see what's going to be created when we run a deployment. When we're ready to deploy, we can now run CDK deploy, and this will go ahead and deploy all the different services that we've created in our CDK project. So this is going to be our AppSync API, our DynamoDB table, our Lambda function, as well as all the IAM resources associated. So after this is deployed, we can now go ahead and test this thing out. So to do so, we'll go ahead and open up the AppSync dashboard. And here we're going to look for AWS AppSync in the main AWS console. And we're going to search for the API that we just created there. From here, we can go into the query editor and start writing different queries against our database. So what we're going to basically want to do is create a post. So we can call a mutation of create post. Here we'll pass in the properties that we need. So we'll pass in the ID, the name, or the title, and the content. We can now run a query to kind of query against our data that should now be there. So we'll do a list post query, and we'll also return the ID, the title, and the content. We can now go ahead and take a look at the event that we've logged out earlier. So to do so, we'll open our Lambda function data source, and then we'll open the logging and open up CloudWatch logs. And this is a good way to kind of see what's going on in that event. So like we mentioned in the presentation earlier, you get all of this information. So here you see that we have the arguments, we have the requests, we have the headers, and we have all of that metadata that we might want to use within the execution context of the Lambda function. And if there was an identity, if there was a sign-in user, the identity would be present, but in this case, since there isn't, it's just null. And then finally, we'll scroll down and we'll see that we have that GraphQL info object. And the info object, again, is what kind of holds metadata about the GraphQL operation itself. So we have the selection set list, we have the selection set GraphQL, the parent type name, and the thing that we used, the field name of create post or list post. All right, and that's it. So that's kind of how you create an AppSync API using CDK. So I encourage you to check out AppSync with CDK, with Amplify, with whatever your favorite CloudFormation provider is. If you're interested in learning more, check out our documentation. Check out the Amplify documentation as well. There's a lot of good AppSync stuff there as well. And I appreciate you coming and watching this presentation. I hope you learned something, and I hope you enjoyed the rest of reInvent.